Hello everyone, welcome to MathsTuber. This is the part 3 of trigonometry where we are going to uh, talk about exercise 8.1. So we have already done first, third and sixth question in the previous parts. So let's start with the second part here. Second question. So in the figure is given in the book. So in this figure, a triangle PQR is given and the sides of the triangle are also given. This is 13 centimeter, which is the hypotenuse, and the perpendicular is given 12 centimeter. So we have to find this QR here. So using Pythagoras theorem, we know that PR square is equal to PQ square plus QR square. So 13 square is equal to 12 square plus QR square. 169 is equal to 144 plus QR square, and QR square will be equal to 169 minus 144, which is equal to 25. So QR will be equal to under root 25, which is equal to 5 centimeters. So now we have to find out the value of tan p minus cot r. So first of all, we will find out tan p here. According to angle P, so tan P is basically perpendicular upon base, and according to this angle P, perpendicular is QR and base is PQ. So it will be 5 upon 12. And we have to find out cot R as well. So according to angle R, base will be QR and the perpendicular will be PQ. So that will also be 5 upon 12, and therefore tan P minus cot R will be equal to 5 upon 12 minus 5 upon 12, which is equal to 0. Right? Now the next question is, we have already done the third question. So let's move to the fourth question, which says that 15 cot A is equal to 8. So we have to take this 15 to the other side so that cot A will be equal to 8 upon 15. And we know that cot A is actually equal to base upon perpendicular. So we can multiply because it's the ratio. So I have told you that we can multiply both numerator and denominator by k, because k is the common ratio here. So we will form a triangle here and mark this angle as A, B, and this is C. So according to angle A, base is AB, so it will be 8k, and perpendicular is BC, so it will be 15k. And now using Pythagoras theorem, we will find out the value of AC from here. So AC square is equal to AB square plus BC square, which is equal to 8k square plus 15k square, and that will be equal to AC square is equal to 64k square plus 225k square, and if we add them, it will be 289k square. So AC will be equal to under root of 289k square, that will be equal to 17k. So we got the value of hypotenuse as 17k, and now we want to find out the values of sine A and sec A here. So sine A will be equal to perpendicular upon hypotenuse. Perpendicular is 15k divided by hypotenuse is 17k. So k will get cancelled and the answer will be 15 upon 17. Similarly, sec A is hypotenuse upon base. So the value of hypotenuse is 17k and the value of base is 8k. K will cancel out. So the answer will be 17 upon 8. Right? Now, similarly, fifth question is also the same, where sec theta is given 13 upon 12, and we have to form this triangle and we have to find out the other trigonometric ratios, that is sine theta, cos theta, tan theta, cosec theta and cot theta. So it is similar to these questions, so try it by yourself. Now let's come to the seventh question. Sixth question we have already done. Now in the seventh question, it is given that cot theta is equal to 7 upon 8, and we have to evaluate the answer for the two parts. But before that, we have to go for the triangle here. We have to draw a triangle and find out the unknown side. So cot theta is basically base upon perpendicular, and we can multiply both numerator and denominator by k. Now form a triangle here and take this angle as theta. Let us say this is ABC. So according to angle theta, base is AB, so it will be equal to 7k, and the perpendicular is 8k, which is BC. So using Pythagoras theorem, AC square is equal to AB square plus BC square, which is equal to 7k square plus 8k square. So it will be 49k square plus 64k square, and that will be equal to AC square is equal to 113k square. So AC will be equal to under root 113k. So the value of the hypotenuse is under root 113k. Now in the first part, we want to find out the value of 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. So we have to put the value of sine theta and cos theta here. Sine theta is basically perpendicular upon hypotenuse, and the perpendicular here is 8k according to theta, and hypotenuse is 113k, root 113k. Similarly, 1 minus 8k upon under root 113k. Similarly, we can find out the value of cos theta here, which is base upon perpendicular, base upon hypotenuse, which will be 7k upon root 113k into 1 minus 7k upon root 113k. So k will cancel out each other, and you can see here that in both the numerator and denominator identity, we can apply a square minus b square, because this is a plus b into a minus b. So it will be 1 square minus 8 upon root 113 whole square divided by 1 square minus 7 upon root 113 whole square, right? Now if we solve this, you will get 1 minus 64 upon 113 upon 1 minus 49 upon 113. And if we take LCM in both numerator and denominator, it will be 113 upon minus 64 upon 113. Similarly, upon 113 minus 49 upon 113. Then 113 will get cancelled. 113 minus 64 will be 49, and 113 minus 49 will become 64. So this is the value of the first part. Now let's come to the second part here. So the second part is we have to find out the value of cot square theta. And we already know the value of cot theta, which was given in the question, that was 7 upon 8 and its whole square. So it will be 49 upon 64. And this will be the answer. Similarly, in the eighth question, we have to prove or check whether 1 minus 10 square a upon 1 plus 10 square a is equal to cos square a minus sin square a or not. So you just need to find out the values of tan a, sin a and cos a using the given trigonometric ratio, which is cot a is equal to 4 upon 3, right? So eighth question, you are given with 3 cot a equal to 4, and from here you can find out the ratio cot a as 4 upon 3, which is base upon perpendicular. So we can multiply both numerator and denominator with k. So it will be 4k upon 3k. Now, if we form a triangle here, this will be A, this will be B, and this will be C. So base is AB, so it will be 4k, and perpendicular is BC, so it will be 3k. And using Pythagoras theorem, AC square is equal to AB square plus BC square, and that will be equal to 4k square plus 3k square. And if we square them, it will be equal to 16k square plus 9k square. So AC square will be equal to 25k square. AC will be equal to 5k. So the hypotenuse becomes 5k here. And now we have to find out the values of sin A, cos A, and tan A, as we want to use this in proving the given question. So sin A is perpendicular upon hypotenuse, which will be 3k upon 5k, so it will be 3 upon 5. Similarly, cos A will be equal to base upon hypotenuse, that is 4k upon 5k, that is 4 upon 5, and tan A will be perpendicular upon base, that is 3k upon 4k, that is equal to 3 upon 4. Now, we have to check whether 1 minus 10 square a upon 1 plus 10 square a is equal to cos square a minus sin square a or not. So taking LHS here, which is 1 minus tan square a upon 1 plus tan square a, right? We have to now put the value of tan a in both the numerator and so putting the values of tan a here, it will be 1 minus 3 upon 4 whole square upon 1 plus 3 upon 4 whole square. So we will get the value as 1 minus 9 upon 16 upon 1 plus 9 upon 16, and that will be 16 minus 9 upon 16 plus 9 upon 16, and 16 will get cancelled here, so it will be 7 upon 25. Now we have to take the RHS here, which is cos square A minus sin square A, and now put the values of cos A and sin A here. So the value of cos A is 4 upon 5, so it will be 4 upon 5 whole square, and the value of sin A is 3 upon 5, so it will be 3 upon 5 whole square. So 16 upon 25 minus 9 upon 25, taking LCM here, so it will be 16 minus 9 upon 25, that is 7 upon 25, and clearly LHS is equal to RHS, and hence we can say that 1 minus tan square A upon 1 plus tan square A is equal to cos square A minus sin square. Now you can try the 9th question by yourself, and let's do the 10th question, which is an important question. In triangle PQR right angled at Q, so this is a triangle PQR which is right angled at Q. PQ is given as 5 centimeter and PR plus QR is given as 25 centimeter. So we are going to find out the value of PR in terms of QR as 25 minus QR, and the value of PQ is given 5 centimeter. So using Pythagoras theorem, we will get PR square is equal to PQ square plus QR square, and that will be the value of PR we have here from equation number 1, which is 25 minus QR whole square is equal to 5 square plus QR square. So now if we apply the identity A minus B whole square, so it will be 25 square plus QR square minus 50 QR, that is A square plus B square minus 2AB is equal to 5 square plus QR square. So on both the sides plus QR square is there, so it can be cancelled out. Now this will be 625 minus 50 QR is equal to 25. Taking this 25 here, it will be 625 minus 25 is equal to 50 QR. Now this will be 600 is equal to 50 QR. 600 upon 50 is equal to QR. And if we cancel out these, you will get 12. So QR will be equal to 12 centimeter. Right? So if the value of QR is 12 centimeter, then from equation number 1, the value of PR will be 25 minus 12, that is equal to 13 centimeter. So the hypotenuse will become 13 centimeter now. Now we have to determine the values of sin P, cos P and tan P. So here, according to angle P, sin P is perpendicular upon hypotenuse, and according to angle P, 12 centimeter will be the perpendicular, and 13 centimeter will be the hypotenuse. So it will be 12 upon 13. Similarly, cos P is base upon hypotenuse. Base is 5 centimeter and hypotenuse is 13 centimeter. Similarly, 10P will be equal to perpendicular upon base, which will be 12 upon 5. So these are the answers for the 10th question. And now 11th question, where we have the uh, true false question and we have to justify the answers. So the first question says that the value of tan A is always less than 1. Actually, it's a false, and the reason behind is that tan A is equal to perpendicular upon base, right? And if it is saying that it is always less than 1, if tan A is less than 1, then perpendicular upon base should always be less than 1, and perpendicular is less than base if we take this base to the other side. And is perpendicular is always less than base? No, it's not the case. Perpendicular can be or cannot be, may be or may not be less than the base. It can be greater than the base also, it can be equal to the base also. So because it is not true every time, so it's a false here. Now the second is sec A is equal to 12 upon 5 for some value of angle A. So we have to first compare it with its formula, which is hypotenuse upon base. And clearly you can see that if we compare, hypotenuse is greater than the base because 12 is greater than 5. So it is true here. Now the third one is cos A is the abbreviation of cosecant. No, it's a value, it's a abbreviation of cosine of angle A. So it's a false here. Similarly, the fourth part is cot A is the product of cot and A. Cot A is actually not a product of cot and A. Cot is the name of the ratio base upon perpendicular, and those base and perpendicular depends on this angle A. So it's not the product. So it is a false here. And fifth one is sine theta is equal to 4 upon 3 for some angle theta. If we compare it with its formula, which is perpendicular upon hypotenuse, clearly by comparing you can see that the hypotenuse is less than the perpendicular, which is absolutely not true because hypotenuse is the longest side of the triangle. So it is false. So with this, exercise 8.1 is over, and in the next part of this series we are going to learn about the trigonometric table for some specific angles. Thank you.